Hello, my name is Rachel, and I'm currently an Ag Aid intern working under Dr. Maskrcnn with research specifically pertaining to creative robotic solutions for agricultural automation. The topic that I was given to research over the course of these 8 weeks was instant segmentation and diameter estimation of trunks and branches for the purpose of robotic pruning and flower thinning. The purpose of this is to increase quality of apples and discourage overbearing of a crop, as well as to have a more sustainable annual crop. To begin my project, I first had to understand instant segmentation, which is the process of identifying an object of a class where all pixels would correspond to each instance of that class and would be given unique values. My goal for using this would be to uniquely identify the branches on an apple tree. The process of instant segmentation begins with annotating field images of the object being segmented. This was done using an application called Labelbox, where each object was identified as a branch or a trunk. Then the data was translated into JSON files, where coordinates were given for the annotation markings. Here are some examples of the images that I annotated, and as you can see, there's a difference between the trunks and the branches of the closest tree that was recorded. The next step of instant segmentation is Maskrcnn, which is a popular image processing program created by Facebook and available for use on GitHub. I slightly altered the code to suit my personal project and then trained the program using the JSON files of about 200 annotations. This photo is a snippet of what the JSON files looked like, and as you can see, it records the X and Y coordinates of the traced polygons from the annotations. Some of the problems that were faced with running Maskrcnn were the GPU requirements of TensorFlow, which is a major program of Maskrcnn, were too high for my personal laptop, and there were numerous dependencies that the program required, which took a long time to sort through. Another major issue was that after training the model with 200 annotations, it was obvious that the program needed more data because of the skewed results shown in these photos. And as you can see, the branches don't match up with each other, and the data, it's just not being recorded well enough. So this is the Maskrcnn after retraining the model with 440 annotated images. And as you can tell, it's definitely working properly in this one. It's tracing the branches and the trunks like very well. The second step is diameter estimation. In order to do this, I made a program on MATLAB that would measure the diameter of a fake apple by changing RGB values and selecting white circles with the circle detection program. The real diameter of the apple was recorded using a vernier caliper, and then the measurement was translated into pixel length. As you can see, the first photo is normal. The second is after changing the RGB values so that blue and green values were subtracted, and then it was changed into black and white. And then the third picture is after using the circle detection program. I then photographed the apple with real apple trees so that it could be referenced with its known pixel length to the branch's pixel length. The logic of this is to have the apple's pixel diameter divided by its true millimeter diameter and set that equal to the branch's pixel diameter over x. This algebraic equation would give back the true branch diameter. The big issue with this step was that it wasn't pruning season, so the Maskrcnn couldn't detect the trees since they were covered in leaves. To try and solve the issue of it being the wrong testing season for this project, I moved fake apple trees outside to try and have more similar structure to the annotated images. However, this attempt didn't work for what could have been a variety of reasons, including altering the background, having fake flowers and apples being undetectable, and the variety of trees in the distance not being visible. Overall, I believe that a lot of progress was made in this project, and theoretically it should work once it enters the proper testing season. Some of the accomplishments that I made over the course of these 8 weeks were trunks and branches were successfully annotated, apples, trunks, and branches were accurately segmented using a MATLAB program for apples and a Maskrcnn program for the trunks and branches, and the apple diameter measurement model was developed, and a branch diameter measurement model was developed but lacked testing data. Thank you.